Okay, let's take a look at your 5.2 worksheet. And on all of these, they ask you to evaluate the expression. Answer must be in whole numbers or fractions, no decimals. So we got a lot of exponential rules that we talk about today in class. Anytime you're multiplying with the same bases, all you have to do is add the exponents. So this would be like saying 4 to the 6th power. So if you take 4 to the 6th power on your calculator, you'll end up getting 4096. On number 2, 5 to the negative 2 raised to the 3rd power. This is where you multiply the exponents. So originally this will equal 5 to the negative 6th power. But you can't have negative exponents. Remember that negative exponents is like doing inverses, so it causes it to go from the numerator to the denominator. So it ends up being 1 over 5 to the 6th. So if we take 5 to the 6th on our calculator, we'll have 15,625. So it's 1 over 15,625. On number 3, if you remember our rules, we can subtract the exponents. So if you do that, you get 5 to the negative 3 power because you go 2 minus 5. But remember, you can't have negative exponents. It actually causes it to go to the denominator and be positive. Some of you might have just said, well, I have 2 up top, 5 in the bottom, so a 2 crosses out with 2 of them down here, leaving me 3 in the bottom. That works also. 5 to the 3rd power ends up being 125. So this ends up being 1 over 125. All right, on the next one here, when you have a fraction being raised to the power, both the 3 is raised to the 3rd power and the 7 is raised to the 3rd power. So 3 to the 3rd power, if you type that in your calculator, you should get 27. 7 to the 3rd power is 343. On number 5, this one's actually a neat one because if you follow the subtraction rule, 2 minus a negative 9 makes 2 to the 11th. Or the negative would bring it to the top, so it would be 2 to the 2nd times 2 to the 9th, which is still 2 to the 11th. If you do 2 to the 11th on your calculator, you get 2048. On this next one, when you just see the negative 9, it's like saying negative 9 to the 1st power. So this is now like saying negative 9, add the exponents to the 4th power. So if I take negative 9 to the 4th power on my calculator, I get 6561. All right, now here we're going to do ones that have less numbers and more just the variables. So again, just remembering our rules. If it's multiplication with same bases, add the exponents. So this is 8 to the 9th. This one here, it's a power to the power, so you multiply the exponents, x to the 10th power. On this one, you're going to multiply the exponents, but you also have to take 4 to the 5th power. 4 to the 5th power is 1024. Then you get a to the 10th, b to the 15th. So you multiply those exponents, take 4 to the 5th power. That's what the 1024 is. On number 10, you are subtracting exponents, so 8 minus 6 is x to the 2nd. On the next one here, 5 minus 8 is x to the negative 3rd, but we can't have negative exponents. Remember, it causes it to go to the bottom. A lot of times I'll look at it as I have 5 on the top, 8 on the bottom, so 5 will cross out, leaving me 3 in the bottom. X to the 6th divided by x to the 6th, well, that's just 1. Sorry, didn't circle these, so I'll circle them as I move it up, and we keep plugging away. Number 13. I have to take everything to the 2nd power here. However, what I'm going to do is just simplify this 4 divided by 2. 2 goes into 4 2 times. So I'm going to save myself a little bit of work here. So now I really just have to take 2 squared, which is 4. A to the 3rd being squared goes a to the 6th. In the bottom, b to the 4th being squared is b to the 8th. So I actually simplified that number a little bit easier. If you don't, you still should get 4 because 4 squared is 16 if you didn't do it that way. 2 squared is 4. 16 divided by 4 does reduce to a 4 in the top. Number 14, you got to take everything to the 5th power. So this ends up being 2 to the 15th times x to the 10th. 2 to the 15th, well, now we're starting to get a little bit bigger, 32,768 x to the 10th. On 15, you're going to take everything to the negative third power. So when I first do this, I get x to the negative 12, y to the negative 21st. But negative exponents become positive when they go in the denominator. So I get 1 over x to the 12th, y to the negative 21st. 16, x to the 11th, y to the 10th over x to the negative 3, y to the negative 1. Well, if I follow my subtraction rules, 11 minus a minus 3 makes x to the 14th. 10 minus a minus 1 makes actually 11, and I'm done. It looked a lot more complicated than it actually was. So here I have a negative 3, so that's just going to stay in the top. X to the negative 4th causes the x to the 4th to go to the bottom. Y to the 0 power is the same thing as 1. So anything times 1 is just itself. So I just have negative 3x to the 4th. Number 18, going to continue the process. 5 goes into 24 times. So I know I'm going to have a 4 in the bottom. 3 minus 2 is 1, so I just have x in the top, or x to the first. 9 minus a negative 2 makes y to the 11th. So I have x, y to the 11th, all divided by 4. Number 19, x to the 5th divided by x to the negative 2, subtract the exponents. 5 minus a minus 2 makes x to the 7th. On this one here, I'm going to do some reducing. 5 minus 4 makes x to the first, or just x. 2 minus 0 is still 2, so x squared. So it's x, y squared. Anything to the 0 power by definition is 1. On the next one, the negative third power, well, if I take this, I'm going to go 10 to the negative third, x to the negative 15, y to the negative 9th. So I multiplied all the exponents by a negative 3. Well, this goes down in the denominator. 10 to the third power is 1,000. And then it becomes x to the 15th, y to the positive 9th. On the next one, let's do so I have negative 1 minus another 1 becomes x to the negative 2. 1 minus 2 becomes, or 1 minus a minus 2 becomes, oops, sorry, I forgot the negative there, becomes y to the third. But the x to the negative 2 has to go in the bottom and become positive. All right, 24. You're going to have 4 to the negative 2 power, x to the negative 4 power, y to the negative 10 power. So then what we want to do is make them all positive. So 4 being squared is actually 16. Then it becomes x to the 4th, y to the 10th. And we have our answer for 24. Move that up a little bit. Number 25, doing the same process. 2 goes into 6 3 times, so I know I'm going to have a 3 in the denominator. Then as I do the x's, 2 minus 1 is just 1x. And then 1 minus a minus 1 becomes 2, so I get x, y squared, all divided by 3. On the last two, since they're all multiplication, you just do all the numbers and variables. So I have a negative here, but the 7 goes into 21 3 times. So I have a negative up top, but in the bottom here, I have 3 times 3 is 9. I'm going to take care of the x's. 1 minus 5 is negative 4. So since it was negative, the x's are going to go on the bottom. 9, I have one more here, so I'd have 10. And then subtract a negative 2 would make y to the 12th. Then on the very last one here, let's see, the 7s will cross out, the 4 will go into the 12 3 times, so I know that there's a 3 in the top. I have 6 x's in the top, 4 in the bottom, leaves me 2 in the top. So I took care of all the x's, then I have 2 and then 1. And so here I would, oh, and I forgot this one here, so that would cross out with that. So I just have y squared, so 3x squared, y squared. All right, wow, that was a lot of problems there. All right, we'll see you on the next one.